We are live stream now, and
Okay, should I start?
yes, I will let Mohammed Zahar. Uh, Mohammed,
Yes, hi everyone. Can you hear me?
yes, we hear you. You can start.
Greetings everyone. I hope everyone is doing well and staying safe and sound. I'm Ahmed Zahar, member of the IEEE Students Branch, and I would like to welcome you all to the webinar about the IoT presented by Dr. Ahmed Abdelgawad. Before we start, I would like to remind you all to mute your mics. And for those who have any questions, I would like to invite you to wait until the end because we're going to have a Q&A with Dr. Abdelgawad. So I'm going to move to present Dr. Abdelgawad. Dr. Abdelgawad received his master's and PhD from the University of Louisiana at Lafayette in 2007 and 2011. Can you guys hear me?
Yes.
Oh,
Yes, we hear you.
thank you. Okay. He's the computer engineering associate professor at the Central Michigan University. He's a senior at the IEEE. He's a senior member at the IEEE. In fact, he's the current chair of the IEEE Northeast Michigan section, and he's an IEEE SPS Internet of Things SIG member. Dr. Ahmed Abdelgawad, I would like to welcome you and thank you very much for accepting our invite. And we're very delighted to have you here to share your expertise and knowledge with our youth. And it really means a lot to us. So I'm going to let you take it from here, and I hope everyone has a good time.
Okay, thank you for a nice introduction, and thank you for giving me the opportunity to share something about IoT with you guys. So let me start sharing my presentation. I think let me just disable whatever the camera here. Maybe when I share, you can have a full screen. Is that okay?
Yes, just keep your presentation in diaporama mode. So.
Okay. Let me check here something very quickly. Okay, so can you see my PowerPoint?
Yes, we see it.
Okay. Okay, so today I will talk about IoT, give you some introduction, and we'll talk about some opportunities and challenges in IoT. In general, again, maybe before I start to talk about the agenda, I'd like you guys from now to think about a project you can do in your lab, at home, at your university, or whatever. Like, think about a project, because today I will give you an entire introduction about IoT and give you everything from A to Z. I'm not going to go deep for every single section or aspect, but I will give you an entire idea about IoT. So if you would like to do research, you will have an entire or global idea about IoT, what you can do in research. If you would like to do a project, you will have also an idea about what kind of project you can do, what you need to do in order to do a project. So I will give first the definition for IoT. Then I will talk about IoT vision and the enablers. And then I will talk about all component of IoT, starting from sensor and actuator. We'll give you also some information about IoT hardware, some communication technology you can use in IoT. I will talk also about some protocols for IoT. And if you are doing research, I will give you some idea about some software which you can do some simulation in order to do your own research. and then I will give you an idea how to push your data to the cloud, and I will give you some cloud platforms that you can use. And then I will share with you some applications for IoT, and then the opportunities for IoT. And then at the end, I will give you idea about some challenges which you can address if you are doing research. So the definition for IoT is very simple. If you Google it, you will find a lot of definitions, but I like this simple definition. It's two words here: internet and things. We all know about internet. It's a worldwide network of interconnection. But we are using internet. But the good thing here is things themselves they can use internet. So things will use the internet in order to make our life much easier. They will communicate with independently with each other and take decisions. So this is the definition for IoT. That things will communicate using internet with each other, talk to each other independently. They can take decision in order to improve the quality of our life. So the idea is to move from internet of people to internet of things. So before we used the internet for us to send email, to share information, social media and stuff. But now things they can use the internet. And what are things? There is no limitation for things here. So anything you can connect to internet. Even we have some people here doing research in order to connect baby's diaper with internet. So even diaper could be a smart diaper connected to internet. I can someone can say who care to connect diaper with internet, but you can imagine if you connected to internet and then the dad or mom change the diaper on the right time, how much time they can save, how much money they can save, and even they can prevent the baby to have some health issues. So changing the diaper on time, on the right time, could do a lot of things. So again, anything you can think about, it could be connected to internet. And that's why from the beginning I'm asking you to think about a project. Whatever you can do in your home, in your farm, in your car, in your university, or whatever, think about something. And again, don't limit yourself about things. Anything could be connected to internet, and we'll share how we can do this down the line. So everything is connected right now. Even at home, you can find a lot of sensors, a lot of components connected to internet. Our refrigerator, TV, cameras, and many things, thermostat connected to internet. It's not only home, cities will be connected together, and the entire world will be connected together. Not only things will be connected, even we as human will be connected with us. Again, because the goal for IoT is to make our life much easier, to save money, save power, save energy, and you name it. So everything now is smart. But smart in IoT doesn't mean that the things themselves they can take decision by themselves. This is just misleading here. They call smartphone. The phone is not smart by itself, but it gets this feature by connecting our phone to internet. When you connect things with internet, now it became smart. By itself, it doesn't do anything because whatever you program it to do will do. But when you connect things to internet, and then you can, to make it smarter, you can use some algorithms like artificial intelligence, machine learning, something like this. Now you get the smart features from some other application or something like this. So smart in IoT means that your device is connected to internet. Just to make it simple, but Like when we have a smart TV or smartphone, or usually that mean that the device is connected to internet, and then it's not by using some application, some algorithm, and something like this. So why the idea for IoT came to us? Because in general, when we wake up at the morning, we have a lot of questions we ask ourselves. Am I healthy? What is my next bus? Where can I park my car? Did I pay my bill? Do I need to do things? And we get busy with life, so that's why we start to think about how about things that can take care of themselves. They can do whatever I want without even me to think about it. So that's why the idea for IoT came to us. What is the main components for IoT? It's as I said, the first component is things themselves, and then connectivity, data, and analytics. We'll talk about each component down the line, but why IoT is an inflection point? Why we have IoT? We are doing IoT for long, like maybe since 1980 or 1990, but at that time we didn't call it IoT because everything was expensive. It's not easy to do a project or something like that. But now we have IoT available because of many things. The first thing is the hardware is very cheap and very sophisticated. You can buy, for example, Arduino or Raspberry Pi with only 40 euro or less. And this Raspberry Pi is very powerful, and you can do a lot of things using this hardware. So hardware is cheap, and the second thing is connectivity is available, and it's just plug and play. You can have Bluetooth module, Zigbee, Wi-Fi everywhere. So we don't have any problem so far with to be connected to internet. Long time ago, I don't know if you guys experienced this. If you like in 1990, or even late 1990, to connect to internet, you have to dial up using your phone and many other things. It wasn't easy to be connected to internet, but now everywhere you can find Wi-Fi. You can use Zigbee, Bluetooth, and LoRa. Many things. We'll talk about all of them. And even now, development is easy. We have a lot of software is available to do whatever you want to analyze, visualize, and store your data. And the other thing, Moore's law continues. That means we add more transistors to our hardware. That means we can add more features, more capability for our hardware. That's why we start to have IoT. So the vision for IoT is to fuse all physical and digital world together in order to create a network of billions of devices together, and these devices can be able to direct their transport, adapt to their respective environment, self-configure, self-maintain, self-repair itself if need be. And just to look at the history for IoT and see the IoT evolution, we can go back for the era of pre-internet. If you remember when we used our phone to send SMS, and this was like human-to-human communication. This is the first idea about, or the first IoT we did. As soon as it was for human-to-human, but again, this leads to have machine-to-machine, and leads also to have the IoT. And then everything became advanced. We went to Internet of Content. We were able to send email and send some information. Then we moved to Internet of Service. We can have e-commerce. We can order many things online and so on. And so after this, we moved to Internet of People, that we can have social media, Skype, YouTube, and Facebook, and many things. And from then, we moved to Internet of Things, that machine to machine or device to device, we can connect each device to others, and we can they can make decision. So what are the enablers for IoT? The first enabler for IoT is us as a consumer, as a producer, because usually human being, we look forward to have something to make our life easier. So as a consumer, we looking for new device, we asking for many things. This was the first enabler, and then uh, other people can go and try to make this kind of project to you. So this is again a win-win solution that as a human we start to or we are the first enabler. The second enabler is the smart devices. The smart devices are available everywhere. Now you can see a smartphone, smart TV, smart hotel, smart watch, and many things. And the other enabler here is a communication network is available and cheap. And again, small module. You can plug it and play with any device, and then you have internet. And the last enabler is cloud computing. You can use now IBM Watson, Microsoft Azure, Google Drive, and many things. You have even for free. You can have a cloud access to the cloud. You can push your data. You can store data. You can analyze the data, visualize it. Even you can process the data and take an action. So all of this enable us to have the IoT. In order to understand how the IoT is working, this loop here show you how it's working. Like for example, we start first using some sensor to sense data, and then communicate the data with each other. With devices can communicate data with each other, and then aggregate data, store data online. You can process the data, analyze, visualize, and then depend on this you can take an action, and then sense again and continue. You take action and sense, collect data, and analyze it, visualize it, and depend on this you take another action, and so on. And again, depend on how you program it, how you use it, it will adapt and make your own goal for this project. So in order to talk about each component for IoT, let's start first talking about IoT sensor and actuator. Again, as I said, the first component for IoT is sensors and actuator. And we have many sensors available right now, and also very cheap. This some examples. We can have temperature sensor, humidity sensor, pressure sensor, accelerometer, and many things. Here are some examples to give you an idea. If you, again, the deal, just to remind you about the deal, is to think about a project you can do, and the first thing you need to think about: do I have the sensor available or not? What kind of information I will collect? Depending on this, you can decide about sensor. And again, all of these sensors are available online to buy, cheap, and also compatible with many hardware, which we will talk about it right now. Some hardware, IoT hardware, again, you have the sensors, and then you need to connect it with the hardware, and then communicate the data. So the hardware, we have many modules available online right now, available on market. These are some examples, and the most common examples you can start if you would like to do a project. You can start with Arduino, Raspberry Pi, BeagleBone, or Intel Galileo. This kind of hardware is compatible with most of the sensors. And also, again, after you connect sensor to your hardware, you need to communicate. You need to connect to internet. These hardware also are compatible with many Wi-Fi modules, Bluetooth, Zigbee, and many other things. And when you go online, you will find a lot of codes and tutorial how to start with this hardware easy. But how you can decide about which one you would like to use for your project depend on the size, how big is your project you would like to be, depend on how much power you have, depend on security, depend on the cost, and many things. And also you need to find out what kind of sensor you are using, so is it compatible 100% with the hardware you are using or not. So again, I give you some examples here of hardware, but you need to do a little bit research which one to buy before you decide. So after sensors and hardware, now we need to communicate. We need to connect to Wi-Fi or internet. So we can use either Bluetooth, Zigbee, Wi-Fi, LoRa, and many other modules, and all of them are available in market. But the same tools depend also in many things because the devices will communicate with each other. The main concern here, how far you will have these devices, how much distance between all of these devices. So depend on this, you can decide which module you use, and depend on how much data you will exchange between each other, the data rate. Depend on this, you can decide which one you use. Like for example, if you have a low data rate and low range, you can use Zigbee or Bluetooth. But if you have a very long range and low data, you can use GSM, for example, or 4G, 5G, and we'll talk about some of them. And sometimes if you have a high data rate and high range or long range, you can use something we call it LoRa and many other things. The other thing here in communication is 5G, and we start to hear about 5G, and 5G came actually because of IoT, because of many things. 5G is much faster and latency is less than 1 millisecond, but for 4G it was 10 milliseconds. And the most important thing about 5G is the connectivity density, because as I said, in future we will have billions of devices connected with each other. So we'll have in a certain area many devices. 4G can handle only 100,000 connection per kilometer square, and this is not enough. That's why they came up with 5G, which can handle 1 million connection per kilometer square. And also the data rate is much higher than 4G. And even we start to think now, we start to do some research about 6G, because in future we would like to have more speed, more connection density, and more latency. And after you decide about your communication protocol, we have some communication here or some standards and protocols. You can use it for IoT. The most important one is RPL, IPv6, and MQTT. And this is some terminology here. If you in future, if you are doing research, like for example for routing protocol, you can go do RPL. The idea is to give you a wide range of information or global information about IoT. So if you in future, if you see something like this, you can connect what you have. If you do some research, you need to do simulation using some software in order to verify everything is working, and then you can move to hardware implementation. Here I'm giving you two examples of hardware, and the first one is Conteki, and it's compatible with some software, some hardware. So you need also, when you think about your hardware, after you do simulation, you need to smoothly move everything from the simulation to hardware. So you need to find out it's compatible with the hardware you have it or not. Again, this Conteki is compatible with TI-CC 2538, which is a microcontroller, and Atmel, and many other things. The other software is TinyOS. You can use it also for simulation, but you need, again, if your goal is to do hardware implementation, you need to think about which one, TinyOS or Conteki, is good for you. Depend on what kind of hardware you will download your code after, because it doesn't make sense after you just do simulation and 1 year to finish your code, and then when it comes to hardware implementation, it's not compatible, and then you have to start from scratch to do some other code in order to be compatible with hardware. So again, it's you can have also many other platforms you can use. This is just two examples of simulation. The last component for IoT is the IoT cloud platform. After you select your sensors, connect it to hardware, and then use a communication protocol or communication module in order to push your data to internet. And now you need to store this data, analyze it, and take an action. So you need to connect with an IoT cloud platform. Here, some you can have a free account here, and then even they give you the code in order to, if you are using your data, to each one of these. So you can use Google Cloud, you can use Microsoft Azure, IBM Watson, and we have also some other things, Speaks, Siteware, Machina, and many other. Tempo is a good to start with Tempo because it will give you everything, whatever code you need, and it's and compatible with hardware. What you need only to decide is what kind of hardware you are using, and you go to Tempo, decide about everything, and then you can have everything smooth, compatible, and line up together until you send your data to Tempo software or Tempo server, and then you can store the data, visualize the data, and take an action. Again, this is some examples of IoT cloud platform which you can use. This is the main component for IoT, and as I said, all of these devices, they are not smart, so we need to use something, either artificial intelligence or something, in order to, and this artificial intelligence you can implement it in the cloud platform to make it smarter. So AI is like a brain for the IoT, which make it smarter. And AI, it has many other branches like deep learning, image recognition, speech to text, and machine learning, and many things. This graph shows you the main component for artificial intelligence. Also, something you need to know about it if we're talking about IoT, which is blockchain. And blockchain here came to establish security, and we start to investigate how we can use this for IoT, because security is an issue, and we'll talk about this at the end of the presentation. And we start to use blockchain for IoT. The other thing you will hear about here in IoT is fog and edge computing. We talked about cloud computing, and this is, everyone knows what is cloud computing, that we do some processing and stuff on the cloud by itself. But if we are doing some computing or some computations at the node itself, which you have as a sensor, and then the hardware, if you do the computations over there, we call this edge computing. And sometimes when you have the hardware, sensors and hardware, sometimes you send data to a gateway before you send it to internet. We call it fog computing. So you need between the three terminology here: fog, edge, and cloud computing. So, and this is the difference between all of them. Industry 4 also is something came after IoT, because in industry, when the machines start to be fully automated and connected with each other in order to automate the process, we had this Industry 4, and we start to even have some platform or some fabs which is fully automated using the Industry 4. So in general, what is the IoT architecture is we can divide the architecture into 4 different layers. The first one is sensing and identification. Second one is the network construction, and then information processing, and the last layer will be integrated application. And each one here you can use whatever you want. Sensors, depend on your project, you can use whatever you want. Network construction, you can use Wi-Fi, whatever, ZigBee, whatever. And then information processing, you can use any of the data center or any of the cloud platform. And then you can have the application layer, which you can make it smart. Also, we have many IoT applications, and I'm just collecting here some of them. Like, for example, the consumer and home application, smart infrastructure, security and surveillance, transportation, healthcare, retail, industry, and many other applications. What is IoT opportunity? Again, using the sensors or sensing and with some hardware or embedded modules or embedded systems, with some connectivity, you can have a lot of applications. Like I like this graph because it shows you how the IoT is working. Again, the fundamental or the main thing you need is sense data using some hardware, connection to internet, and using some software. You can have a lot of applications here and a lot of services you can do for IoT. I hope now you can have an idea about a project you can do, at least to get your hands wet with something with IoT. But now, if you would like to do some research, if you are doing master or PhD and you would like to do some research, here I will start to talk about some challenges which you can address in order to solve some problems in IoT. The first challenge is big data. And as I said, we will have billions of devices connected with each other, and we'll collect a lot of data. And how to process this data is a challenge, because some of this data will be false data. How we can filter this, and even we have a lot of data, how we can take the right decision. So we need to have some algorithms or smart algorithm in order to get the right decision. And as I said, we have a lot of data because a full of 90% of all the data in the world has been gathered in the last few years. And because we start to have, even for our devices, smartphone, it has at least 6, 7, 8, 9 sensors and collect a lot of data. And this is only one example, and many other things. Our refrigerator is connected to internet, thermostat, car, and everything is connected, so are collecting a lot of data. And we will push this data to the cloud, and then how we can process this data and find the decision is a challenge. So if you would like to, you can do more research in this big data and find some new algorithm in order to handle the data. The other issue is security. Like, for example, if you have a healthcare application in IoT, if pacemaker, for example, for heart, in order to adjust the heart rate, if someone has this device connected to his heart or her heart and communicate the data to internet, and we have a smart algorithm in order to adjust the heart rate and make him or her comfortable, and all the time it's good. You don't have to go to your doctor in order to check anything. Even doctor can access the data and see everything is working fine. Imagine someone can hack the system and go to your data and try to control your pacemaker and make something while you are sleeping. He could kill you. So this is a serious issue. So security will be an issue. We need to have 100% security in our applications, especially with health applications. So, and it's not easy to, or the traditional security algorithm is not good enough to establish or to use it for our IoT. So we need also you guys to think about some new security algorithm in order to improve the security and privacy, and no one can hack such system. And again, it's a trade-off, because people want to use this device, especially for healthcare, because that someone can hack it. So in order for us to convince them to accept such a device, we need to show that we have a 100% secure device, so they can accept it and do it. So again, the traditional algorithm or security algorithm is not good enough. So we need more research in security. Other challenges here is bandwidth and power consumption. When the number of devices will increase, the bandwidth and power consumption will be an issue. So we need also to find out how we can improve this. Networking will be an issue because, as I said, we will have a lot of devices connected with each other. Scalability will be an issue because we would like the devices to come in and out with the communication without any problem. Diversity and even power consumption and stuff. So we need people work and do more research and networking in order to improve the power consumption, diversity, and scalability. The other thing is software. We have a challenge in software here because, like for example, if you are using a Raspberry Pi and you are connected with many sensors and connected with communication protocols and stuff, and you are doing a lot of computations and stuff inside this, you will find your code is millions of lines. In order to debug, if you have a problem, to debug this code, it's not easy. So we need traditional software is not good enough as well. So we need to come up with some new software which is more convenience to debug. It's easy to implement or add more code, add more libraries and stuff. And Raspberry Pi so far code and stuff is working fine, but in future when we will connect many things and we have more competitions and stuff will be a challenge. So we need to come up with some new software. Python is working fine, but down the line we will have other software hopefully. So in order to make it much easier. The other or the last challenge I will talk about it here is standardization. Because this is an issue because, as I said before, things will be connected, homes, cities, the entire world will be connected together. And in order to communicate with each other, we need to talk the same language. We need to have a standardization. So when we communicate, sending data, so we can understand each other, or the devices can understand each other. Yet we don't have a complete standardization for IoT, but a lot of organizations like IEEE, ITU, ISO, they are working hard in order to come up with some standardization to use it for IoT. So this is also a good point of research if you would like to do this. So all of us need to work hard in order to make our life easier. And how we can do this? As I said, we need to address all these challenges and do more research, do more projects in order to have such application or such car. So I don't think anyone now, even if I give you a car like this, you will sleep and have a peace of mind and the car will drive you home or to your workplace. I don't think it's applicable right now, but we would like to have such thing in future. As I said, if you guys working hard and do more research in terms of security, liability, in terms of standardization, and in terms of power consumption and stuff, we could have this car in future. Yet we don't have it, but this is a goal. Our car will be connected to internet, and we will have a fully autonomous car which can drive you everywhere, and even the car by itself can communicate with other cars to avoid traffic jam. Even if the car need to be repaired, it can go and repair itself or fix itself and come back. It can have access to your schedule and come to you even before you think about it. It's many things anyway. It's our duty now to work and do more research, do more project in order to come up with something like this. And here's my information, my LinkedIn link here. If you would like, I'll be happy in future to talk to you. And this, I conclude my presentation, and I'll be here if you have any question.
Thank you, Mr. Ahmed. It was really interesting, the whole presentation. I hope the guys really liked it. It was very delighting and very enlightening. Um, I think we're gonna go to the. I don't know if you guys can hear me.
Yes, we hear you, Muhammad.
Can you hear me?
Yes, we hear you.
Yes.
Okay, I think we're gonna go to the Q&A, right?
Yes.
Okay, guys, if you have any questions, please put it in the messages section. I'll make sure to deliver it.
Can you use IoT? There's a question here. Okay, now we can get actually the question. Let me check here. Can we use the IoT in the mechanical engineering field? Yes, as I said, IoT is not only for electrical or computer engineering. IoT is for everyone, even people in medicine, people in mechanical engineering, material science, people in chemical, whatever. Like for example, the car mechanical engine. In a way, you can connect. As I said, the car will be connected to internet, and uh, we need people from mechanical engineering to work with us so we can do some applications and for cars, for any other mechanical engineering aspect. So yes, for sure, we can use it. Any more questions?
So, for anyone who want to ask the question live, just type it in the chat, and we will let you activate your microphone. For example, we have Haytham. Yes, you can you can ask your question.
Uh, Hello, thank you, Sir Ahmed, for your presentation. Um, my question is, let's say we want to make an IoT system with sensors sensors wired to a gateway, and then multiple gateways that communicate with the wireless protocol to another gateway. When we want to code the interaction between the first gateway and the second gateway, we should probably use some scheduling or some real-time features or something like that. But when we want to code it, when we want to schedule like the emission and reception of the data, if we schedule the emission, how can we schedule the reception? Because if the reception is not scheduled in the same, if the emission and reception are not in phase, the data can be sent but not received, or we can receive data but there is no data to receive.
I think there are a lot of protocols here, synchronous and asynchronous protocol for communication between gateways. Depend on your application if you would like to have real time or the speed of sending the data you can use. We have many protocols, and as I said, RPL is a routing protocol, how to send the data from source to destination, and depend on how you would like, you can do it. But again, if you have a synchronous communication, both gateways can communicate with each other, establish a channel for communication, and then they will start to send and receive and acknowledge the communication and send it. So there is no problem about losing data. I don't think we will have any problem. And again, if you are using synchronous communication, it will be easy. Even asynchronous one also will be easy. Depend on the communication protocol you are using. You can find out some code online, or some code come with the communication protocol you have, and then you can establish a very secure and very reliable communication. I don't think you will have any issue for losing data or anything like this.
So I should just choose the appropriate protocol.
Yes.
Okay, thank you.
You're welcome.
Okay, we have another question from Ali. Um, he asked, do you have any idea on service and resource-oriented architectures? Is there a standardization at this level? He also asked, technology is changing fast. What to choose as the 5G LoRa Sigfox communication protocol?
This is the same question. I see it here on the chat window.
I'm sorry?
This is the question from Ali.
Yes, from Ali, yes.
Okay, let me read it here because it's a long one, so let me understand it first.
Okay, it's okay.
I'm using development of platform for connecting intelligent systems, smart IoT. I can't use project smart agriculture and health and so on. Technology is changing fast. What choose to 5G LoRa? Do you have an idea of services and resources oriented application? Is there any standardization at all this level? Again, for communication using LoRa or 5G depend on the data rate you are using, depend on the range, depend on the cost, because LoRa is not cheap. And if you have 5G available or not, because 5G is not available, for example, in some areas. So which one you use, it again depends on many things. As I said, in order to pick the right communication protocol, you have data rate, density, you have maybe latency, many things, and the cost as well, because it depends if you are using an agriculture application or healthcare application, depend on how much this device will be. So LoRa is not cheap, for example, but it has a very long range, reliable and good. It's expensive a little bit. 5G is, I'm not sure if it will be available or not in your area, but if it's available, it's much cheaper and it has more range.
She must say she has a question.
Yes, hello, can you hear me?
Yes, you can hear me.
So I would first like to thank you, Dr. Ahmed, for your very informative and wonderful presentation. My question is, do you think that we as Arab countries are going to catch up to the other developed countries in the fields of the Internet of Things? Thank you.
Yes, we do. Actually, I was very impressed. I visited Saudi Arabia and Dubai 2 years ago, and they are very advanced in IoT. You can imagine Dubai. I think the first smart city started in Dubai, and they have 5G infrastructure over there, and they start to implement IoT over there. Even in Saudi Arabia, I have seen a lot of companies, startup companies, they doing IoT application and stuff. I think in Middle East, they are in good shape so far, even better than other things. Like as I said, like we have many companies, startup companies, start IoT, and hopefully, and I start to see also a lot of students doing research, master, PhD in Middle East about IoT, and they do projects and stuff. I think, yeah, we are in good shape.
Okay, thank you, sir.
You're welcome. Any more questions?
Okay, Ali asked a question actually. He asked for data transport is MQTT more interesting than HTTP.
Yeah, MQTT it's much easier and more compatible with most of the component and module you have. So my student here, they are using MQTT more than HTTP. So yeah, you go ahead and use it.
Does anyone have any other question? Hatim asked the question. He said, he asked how to secure the data in RTOS systems.
Again, we have two types of security, hardware and software. Depend on what's your end goal. You can start with software security, but in general, software security is easy to break. So that's why we start now to have both hardware and software together, security. Each device will have a signature. In order to communicate, they will check the identity of each device. And on top of this, we will have the software security and do it. This is, again, everything is under research for IoT. But in general, the software security people are using most of the time. But when it will come to IoT, we need to have a hardware security as well. And for example, they will give each device an ID or like national security number or something like this, and then they will keep track if this device hack or do something in terms of security, break some security. They will give it a low score, and then if it's repeated, lower the score again until a threshold, and then this device will not be able to do to connect to the network anymore. This is some ideas anyway, but again, the hybrid security is much secure right now, which is hardware and software together. So this is what I recommend. You try and see.
Okay, thank you, Dr. for your answer. I think Jed Zalawi has something to say. You can say the word.
Thank you, Dr. Ahmed, for your wonderful and insightful presentation. I have a question about, it's like the previous question about the security associated with the IoT, like the cyber attacks when we have the smart cities and the very smart devices.
So what's the question again?
The part of the cyber security attacks.
The bar of the cyber security attack?
On the IoT devices.
What do you mean by bar?
If we have like, can we have some attacks to the IoT devices, like cyber attacks or?
Yes, that's what I said. If you have any device, if within a network, again, all the devices or components communicate with each other. So if it's open, everyone is connected with each other. So someone can go in the system and give you wrong information, and you take a wrong decision. This is, again, it's an attack. Or someone is not welcome to be in the network, can go in the network and steal the data, get the information. That's why security is an issue, because so far we design it in a way whoever is within this range can communicate with each other, exchange data to make decision. So it's easy for another device to come and inside the system and hack the system, or pretend it's a good device and then steal data, change data, give wrong data to make a wrong decision. And this is, again, it's an attack. Yeah, that's why we need people to work in security in order to verify this is the right device to communicate with, this is the right information, to verify whom I am talking with. Is it a normal device or a device that's trying to have an attack to or attack our system or something like that?
Thank you.
What?
Okay, Ali asked a question. He said, "What about narrowband IoT? Is there a future? What are the differences with LTE-M?"
Again, this is all of some of the communication protocol. In future, I'm not working in general with communications, but in future, I think we will use more 6G and stuff because the trend or the future, they will have Wi-Fi and 6G available to the entire Earth. They will run it. Everyone will have access to 6G from anywhere. That's the future. But again, because IoT again, it could be local. You can use a narrowband IoT. You can use the light one as well. It depends on again the availability and the cost, data range, and as I said, we cannot say it period like this. This one is better than the other one. We can say this module or this protocol is good for this project, and this one is good for the other project. That's why you need to do some research in terms of data rate, density, latency, cost, and range and stuff, and then you decide which one is good. So all of them are available, but depending on what kind of project you are doing, you can pick the right one.
Thank you, Dr. Ahmed. Haitham has a question. You can go ahead.
My question is there any AI or machine vision or other AI framework that can be run on fog computing?
Yes, on fog computing, you can do whatever you want. You can use the same platform, same algorithms, same protocols you're using for cloud computing, but it depends on the capability because usually the gateway or fog computing, the device is not powerful enough. You don't have enough power. But if this gateway has enough power, has more capability, you can do whatever you want. But in general, usually, as I said, power is an issue. That's why usually it's better to push everything to internet, to the cloud, and then on the cloud you don't have any limitation in terms of power, computation capability, in terms of speed and stuff. But if you are using a very powerful gateway, you can use it as cloud. You can use the same application, same protocols, everything. But again, depend on what kind of gateway you have.
Well, my question was more: is there any framework for resource constrained devices? Like if we only have, for example, a Dragon CPU or an ARM Cortex, are there any framework that we can implement on those microchips?
I'm not aware about any, but if you go to this hardware, they will tell you what kind of platform is compatible with it. Usually, if you check their data sheet or check with their customer service, they can tell you what exactly is compatible with them. Because again, I didn't use every single module, every single hardware. Students do more, but I think it's a good start. You can communicate with them and check the data sheet, and you can find out, I think, which one is compatible.
Okay, thank you. I have another question. When we want to choose, well, in IoT in general, when you want to choose communication schema or pattern, can we use mesh communication or are star communication more like are better to use? And because I think if we use mesh communication, when we want to use a protocol or a communication protocol, I'm afraid that we will have the port busy with one device and can't receive data from other devices.
Yes, I understand. Yeah, mesh is in general is good for wireless sensor network, and depend on your application because again, like for example, if you have a real-time communication and or priority for a device, that's why you need to pick the right one because sometimes mesh will not be good enough to send the data in right time. You need to work more in the RPL, the routing protocol, in order to, even if you are using the mesh, you can set it up in a way, whatever you want. You care more about timing, you care more about power consumption, because you can select a route which can send you the data more reliable, but could be consuming more power, could be delayed, could not be fast enough. Depend on the speed, depend on the power consumption, depend on the reliability, because sometimes also you can send it fast, but you can send the data itself could be affected and has here or there. And that's why, again, as I said, when you do a project, you need to do more research or more simulation in order to find which protocol, which hardware, which software is better for you to use. If you use mesh, it has goods and bads. Is good enough for your project or not? When you use a star or when you use any routing protocol, you need to ask yourself what's your goal. Is the time, power, reliability, or what? And depend on this, you can decide. As I said, there is no one answer which one is best. All of them are available. Each one has some good and bad. Depend on your project, depend on your goal, you can pick the right one.
Okay, thank you, sir.
You're welcome. There's a question here from Khadija. Let me read it. If you would like to use IoT a video game, what are the tools we have used programming language? Yeah, if you are using for video game, IoT will be a challenge for you because for video game you need real time. And in order to do this yourself from scratch will be a challenge. But they have some, you don't have to use it for IoT. If you care more about video games, they have some other platform you can use. You can connect to, I think, Microsoft and some other companies. They made it online right now. You can access and play game online. But if you have devices and like Raspberry Pi or Arduino or BeagleBone and you use it for video gaming, I don't think you will have a right device because this will delay everything. I don't think now with what we have in IoT, it's not easy to play video game or do some video game application. Another question for Mahmoud. Using the IoT or the artificial intelligence in the medical field, is it really safe for us? I mean, yes, again, that's why we need to work with standardization. Maybe Wi-Fi and communication could be a risk a little bit, like any other Wi-Fi. If you are using 5G or 6G or Wi-Fi, the same risk you're using for medical applications, the same if we are using for our cell phone, for other devices. I don't think we'll have any issue with safety and stuff for medical application because we start to see a lot of application for IoT and artificial intelligence in medical. And all of them are working with in safety, and before they get approval, they go through a lot of FDA. There is an organization here, for example, in the US, before for medical devices and stuff. they have to approve it and go with standardization and go with some code in order to verify it's safe for our health. So I don't think we have any issue in if we are using medical application for IoT. No problem at all.
Thank you, Doctor. I think there's a question from Shayna, since we talked about 5G and 4G. She said, what are the best options for device connectivity? Wi-Fi, radio, or cellular?
Again, as I said, when you use a communication protocol, it depends on what's your goal in terms of cost, speed, power consumption. Depend on what you're doing, you need real time or not, and then you can pick the right one, 5G or Wi-Fi or Bluetooth or LoRa. Or for example, if you have a very long range, for example, so Wi-Fi could be good, 5G could be good. If you have a small application indoor and the range is very small, Bluetooth could be a good option. Zigbee, because it's cheaper and can do it. But again, you need to do research and find out how much it will cost you. Money is an issue. How much or the speed, power consumption and stuff, and then you decide.
Thank you, Dr. Ahmed. There's a question from Selma. She said, what advice could you give someone that wants to start learning IoT?
I think Raspberry Pi is a good device to start with. Raspberry Pi is cheap, and you will find a lot of code online available for free. You can use with many systems, and it's compatible with many communication protocol. And even if you would like to push the data to internet, it's compatible with Tempo, Cloud, Google Cloud, and many other things. So Raspberry Pi is a good start. Even when I have a new student, usually I ask them to start to learn about Raspberry Pi. Arduino is the same, but Raspberry Pi is more powerful. Arduino also, if it's available, will do a simple project, will be fine as well.
Here's another question. What advice would you give someone who's new to the IoT field?
Where is the question? From where? I didn't. Can you repeat the question? I'm sorry.
Yes. What advice would you give someone who's new to the IoT field?
What device we using?
Advice. No, advice.
Advice.
Yes.
Then if you are doing project, again, I give you a lot of information to do a simple project. If you are doing research, I think security will be a good field to do research in IoT.
Okay, thank you, Doctor. Are there any questions? Okay, since there are no questions, I have a question. So, do you think that we are capable of to fully adopt the IoT field in Arab countries?
Yes, yeah. I think, as I said, the technology is easy to learn and it's available. I don't think we start to see all of these component sensors and stuff available in market, even in Middle East or in Arab countries. And I start to see it everywhere now, as I said, in Gulf area, in Morocco, Algeria, and even Tunisia. I start to see a lot of people working over there. I think, yeah, and a lot of students are interested about IoT, and also I start to see a lot of faculties, and they are teaching IoT in our universities. So yeah, I think it's promising, and we will have, hopefully, we will have a lot of projects and research and IoT in our Arab country.
Hopefully. Thank you, Doctor. more like logistics wise, I think Arab countries lack a lot of infrastructure or just resources to fully adopt this kind of technology. Uh,
Yeah. Yeah.
so, is there any options or like solutions to that?
Solution? It's only for Arab country, or
Uh, uh, yeah, mostly Arab countries.
again, I don't think there is a only solution for Arab country. I think it's better to see what the other countries they are doing, what we need, and what the hot topics of IoT, and then work shoulder to shoulder. It's not something we need, just something for us as Arab. It's what's need to be done, and we need to be up to date, educate ourselves what's going on everywhere, and to start to be a part of this in future. And again, it's not only use what they are doing, and we can have our own again, because again the software, hardware, and stuff. It's easy for even for kids in high school or even middle school. Now they can do programming. They can use hardware. So I think it's a good chance for us now to start to compete, not just to use like others' devices and applications. So we can come up with our own software, hardware, and stuff. Not from scratch, but some devices we can put something together. We can do programming, and we can have more applications which is compatible with us as Arab country, and also good for others to use. We can have our own because different culture, different application, different stuff, but we need to also to look at what others are doing and learn from them and add to them.
Okay, thank you, sir. Yeah, that's exactly what I want to say, because we've seen the competition, the Arab IoT and AI challenge, and would you encourage youngsters or the youth to enroll in this kind of competitions? And
yeah, that's good. Yeah, I think this is how you learn. If you have a competition, you open it for everyone, and they learn from each other. So, yeah.
Okay, thank you.
Yeah, you're welcome. Any more questions?
Are there any platforms to simulate or like, for example, simulate communication or simulate power consumption or something like that?
Yes, I give two examples in the presentation. Kentucky and TinyOS is a software which can simulate you everything for you, even communication, power consumption, packet lost, and latency, and many things. Yeah. TinyOS or Kentucky is a good two platform you can use for simulation.
I used Kentucky, but I didn't find how to measure power consumption.
No, you can. I think don't depend on. I don't know which version you have, but I have my student here. But you need to dig more inside and find out how to do this. But I think at least, yeah, you can see the power consumption. But maybe you need to see where it's compatible. You need to define which hardware you are using and define the libraries and stuff. But if you spend more time or Google more, you will find a way how to.
Okay, thank you.
Yeah, you're welcome.
Doctor, there's a question from a friend. She said, how can we protect as citizens ourselves and our privacy from IoT threats?
Can you repeat it again because your voice is cutting?
Yes. How can we protect, as citizens, ourselves and our privacy from IoT threats?
How we can protect ourselves from IoT privacy?
Yes, how can we protect our privacy?
Again, if you remember when Facebook started, people at the beginning hesitated to put their email and password. Everything at the beginning is people resist to use because they don't know what's going on. I think you need to be involved, and you don't have to worry about privacy and information that much unless if you are worried about specific information, don't share it, don't put it online, don't connect it to internet, but at least start to have some application to improve our life. Like for example, my home temperature and humidity, who care if someone knows my home temperature? So start with something like this and be involved, improve your quality of life. And whenever we will see everything is secure, there is no problem, I think we will have everything gradually connected and then accept that. But if you really don't want to share or to share the information, or you worry that much about personal information, don't share it, don't connect it to internet. But at least if we live in this way, we are going nowhere. So, but at least we need to be involved in IoT. Believe it or not, in future IoT will be everywhere. Smart city will be everywhere. We need to be aware of it. So at least we start with something simple about information. Doesn't harm me if someone know about it. Like for example, if you have a medical device, critical medical device, you don't have to start with something like this, but you can start with your room temperature, humidity, light, and stuff like this. If someone know what your room temperature is, so I don't think it will harm you in any way. Yeah.
Thank you, Doctor. There's another question from Manal, I guess. She said, what area of research in IoT would you advise someone to focus on for a PhD?
As I said, yeah, for IoT, for PhD, I think security, routing protocols will be a good field for PhD in general. But it depends again what is your background or what you would like to achieve. But security, so far, it has hardware, software, and we need it more. So you need to just to do some literature review, find some good papers, and define a new problem, and then start to solve the problem. But yeah, security and routing protocols is a good field for PhD.
Thank you, Doctor.
Yeah.
If anyone has any question, please don't hesitate. Don't lose this chance. It's very valuable. Ask your questions. Okay, Doctor, I don't think there are any more questions.
Okay, no problem. Yeah, it was nice talking to you guys, and I wish you the best and good luck.
So,
Thank you, Doctor, for your valuable time. It was very interesting and very enlightening. We got the chance to have an insight on the IoT field, and thank you very much. It was really an honor. You're welcome. Okay,
yes,
goodbye.
thank you, Dr.
Thank you.
Ahmed, for your presentation and for answering the questions of the participants. And I would like also to share with you the thanks of Mr. Professor Dr. Mohammed Saidi, who is the founder and the past chair of IEEE Morocco section, and also our counselor. He wasn't able to join us today, but he will get in touch with you later. So thank you
Sure.
so much,
Yeah.
Dr. Ahmed, for your insightful and interesting presentation, and also for sharing knowledge with us.
No problem.
I would like also to thank all the participants with us today in this meeting. Thank you very much for your questions, and let's keep in touch on our social media pages. So make sure to follow us so you will never miss our upcoming webinars. Thank you so much again, Mr. Ahmed, and
You're welcome.
yes,
Okay. Bye bye. You have a good day. Bye.
goodbye.
Well,
Yes, thank you, everyone.